So now let's talk about what happens to delta G when we are at equilibrium. So remember, Q is the expression we write when we're not at equilibrium. But what if we are at equilibrium? So I don't know if you remember, we said that delta G is negative when it's spontaneous. Okay, we said it was positive when it was non-spontaneous. And we said it's 0 when it's at equilibrium. So let's see what happens now when we're at equilibrium. Okay, so if we're at equilibrium, delta G is 0. So I'm going to write 0. Okay, and that equals the standard delta G plus RT ln. Now instead of Q, let's put K because we're at equilibrium. So K or KEQ. So if we rearrange this a little bit, we get delta G is minus RT ln of K. Okay, and this is going to be a very useful equation for us to use. And K can be any KEQ. So what are the sum of the KEQs we have? It can be KW, it could be KA, it could be KB, it could be KSP, it can be any K at all. Okay, when you plug in, if you're plugging in for K, make sure your gases are in ATM, just like before. Make sure your solutions are in molarity, and make sure your temperature is in Kelvin. Okay, and again, make sure your R is 0.00831 kilojoules per mole Kelvin. Okay, so we could use this to find the KSP for lead 2 chloride at 25 degrees Celsius. Okay, right? Our equation is delta G is minus RT ln of K. So the first thing we want to do is use a table of free energies of formation. Again, you have that table, so you can follow along with me if you want to. So let's write the equation we're talking about. We're talking about lead 2 chloride, which is a solid, dissolving to make lead 2 ion and 2 chloride ions. So when we go to find the delta G0, the standard free energy from the tables, okay, it's going to be the free energy of formation of lead 2 ion, which is minus 24.4, okay, plus 2 times the free energy formation for chloride, which is minus 131.2, plus 1 times the for that, so 314.1. So if you do all that out, you get 27.3 kilojoules. So right off the bat, you should maybe notice that that's a reaction that's pretty non-spontaneous. It doesn't happen very much. Well, we kind of know that, right? We know that this solid is pretty much insoluble and doesn't dissolve very much. All right, so that sort of matches up. That's a nice little check. So I'm going to take this equation and I'm going to rewrite it. ln of K is minus delta G over RT. So now we've got our delta G, so negative, because there's a negative in the equation, 27.3 divided by R, 0.00831, okay, get into kilojoules, times the temperature, which is 298. So if you do that, you get the ln of K is negative 11.0, and if you do that out, inverse natural log on your calculator, the K, which is KSP, is 1.7 times 10 to the minus 5, which seems about right. Okay, so you can use this equation to find K's. So that's kind of a useful thing to know.